Today we are finishing up lesson 11.1, Intro to Limits, Introduction to Limits. As we covered yesterday, the limit is x goes to 1 of this function. Just a recap, we check the x value at 1, and then moving up from there, we look at where the function is coming from on both the left and the right. They need to approach from the left and the right for it to be true. Okay? And so in that one, it specifically worked both from the left and right. It looked like it was approaching y is 2, so 2 is our solution to that one. Next one, as x approaches 0 for the function x plus 1 over x, you notice it's 0. If we're looking at x is 0, right, we're looking left and right on that center line. Right, center line right here. Right, so on the right side, we approach positive infinity. On the left side, we approach negative infinity. So since those don't match, we're going to have no solution here. So in this one, the limit does not exist. B and E, again, does not exist. Moving on, for a piecewise function here, 13, f of x equals 3x plus 1 when x is greater than or equal to 3 and equals 2x minus 3 when x is less than 3. Okay, so in this case, x approaches 3's, right? So on the left side, you would still look at this one on the bottom. We would still look at the left side. So going here, we approach a value, it looks like it's about positive 3. But on the right side, we are way up here, right? Because on the right side, we are approaching 3 from above 3, right? So 3.001, 3.1, 3.0001. And we're at this point, which is much higher. Since they do not match, this is also a does not exist. DNA does not exist. One more here. 14, f of x equals 2x minus 3 as x is less than 4, and it equals 4x minus 11 for x greater than or equal to 4. And of course, again, we're checking x equals 4, right? What's the limit of fx is x equals 4. So on the bottom, the purple, coming from the bottom, we are approaching the value right here for y. So 1, 2, 3, 4, 5, right? From the bottom, y equals 5, right? Now we also have to look from the top side. From the top, we've got going down, we're hitting the same point. Now it doesn't matter that for the top one, we are actually using a different function and our slope changes. We're still approaching the same value of y equals 5. So in this one, our limit equals 5 because it approaches the same value from both sides. That's all we're checking. Lastly, 15, the limit as x goes to 0 of cosine of 1 over x. Okay. So 1 over 0 doesn't exist, right? But plugging in our values here, we plug in 1 over pi, that's the same thing as cosine of pi, which is negative 1, right? So that would be cosine of pi. 1 over 2 pi is the same thing as cosine of 2 pi, right? So that would give us positive 1. And then we're just going to oscillate between those two values where it just kind of flips back and forth. And then this one's going to be 3 pi when it's 1 over 1 over 3 pi. And we get negative 1. It's flipping back and forth. Because it's flipping back and forth at 0, right, we're not going to equal 1 or negative 1. So it's going to not exist. Does not exist. Okay. Because it's flipping between the two. If it was consistently jumping just always the same value, then we could follow the pattern and we get our answer, right? But as 1 over 6 pi, we're getting closer and closer to 0. As we're moving to the right here, we're getting closer and closer to 0 from a positive standpoint. If we put a negative in, it would actually have the same answer. That's why it kind of repeats on both the left and the right side, kind of repeat. Moving on, the basics of the limits. So here's some basic rules. Given b and c are real numbers and let n be a positive integer, 1, the limit of b as x approaches c is b, right? So the limit of a number, the limit of 5, as x goes to 3, is still 5 because there's no x value in there for it to change. So the limit of x as x approaches c, part 2, is going to be c, right? which is just 1x, limit of c, x goes to c, so limit of x is x goes to 3, limit of 3 is basically just plugged right back in. Number 3, limit is x goes to c of x to the n, again, is basically substituting c in for n. And then next, lastly, limit of x as it goes to c of the nth root of x becomes the nth root of c, assuming n is even. N needs to be even, and c also has to be a positive number, otherwise we're going to end up with imaginary. C is positive. Okay. Moving on. We have properties of limits. All right, so let b and c be real numbers. Let n be positive integer. Let f and g be functions with the following limits. So given the limit of f of x as x approaches c is L, and limit of g of x as x approaches c is k, right? So just follow those two, right? We can do scalar multiplication. Limit of x of b times f of x as x goes to c becomes b times L. Right? So if we have the limit of f of x equals 3, and then we have the limit of 3f of x, we're going to get 3 times 3, which is 9. It's basically all we're doing there, multiplication. Well, if we're adding or subtracting, again, now on part 2 here, the sum and difference, the limit of f of x plus or minus g of x as x goes to c equals L plus or minus k, right? It's going to match whichever one. Those will match. So if we're adding the functions together, then we're going to be adding the what they approach, their limits together. Product, limit of f of x times g of x as f goes to c, again going to the same number we start with, is L times k. They're going to multiply. Quotient, same idea. The only difference is k cannot equal 0. Whatever we're dividing by cannot equal 0. So it's been basically true for everything we've done where we cannot divide by 0. Lastly, power rule, limit of f of x to the nth power as x goes to c is L to the nth. Right? So you basically just follow what they're doing. If you're dividing, you'll divide. If you are multiplying your functions together, you're going to multiply your limit. If you're adding or subtracting, you're going to add or subtract your limit. So find the limit by direct substitution. Limit of x cubed as x goes to 4, this becomes 4 cubed, which is 64. Next one, limit of 7 as x goes to 10. This is like example, I believe 2 x go equals 7. Sorry, example 1 of basic limits is that one. Next, limit of x squared minus 4x plus 8 as x goes to 3. We plug it in and multiply. Right? So we've got 3 squared minus 4 times 3 plus 8. I've got 9 minus 12, negative 3, plus 8 is positive 5. Last one here, limit as x goes to 2 of x squared plus 5x minus 35 over x plus 4. Again, just plugging in 2 squared plus 5 times 2 minus 35 over 2 plus 4. We get 4 plus 10 minus 35, 14 minus 35 is going to be negative 21 over 2 plus 4, which is 6. Negative 21, 6 can be simplified. We get negative 7 half. And that is a perfectly fine answer. The homework was already given to you. In case you missed it, there's the homework, and you can pause it on.